Electrician Live with your host, Paul Abernathy and Jay Grunberg.
What up, everybody? Welcome to another episode of Electrician Live. My name is Paul Abernathy, one of your hosts, and with me, as always, the co-host with the mostest out in Colorado, the basement king himself, Mr. Jay Grunberg. Welcome, as always. I can't hear him now. There you go. You got to take the mute off.
What up?
All the buttons that I gotta push here, and all you got is one button to unmute yourself, and I've got like 15 buttons here that I gotta push, dude.
Well,
whatever.
Right before we got on, my little one just was screaming like crazy, so I had to hit the mute button. Man, she is not happy right now. I don't know what they're doing up there, but she's not happy.
That's more important. Well, welcome to the show. As always great to see you. I know we chat during the week and all that type of stuff. It's always great to see your face here on Thursday nights. How is things in Colorado? Whoa, wait a minute. Lift that up again. Whoa. What is that? Whoa. Is that apple juice?
This right here is apple juice, my friend.
Okay, in a Milwaukee
And check
cup.
Out the mug.
I see that. How come it's not electrify? Notice the swag? Look at that.
The swag, bro.
Look.
The swag.
Look at that. Look. Okay.
I like it, man. I love that.
So
that's
anyways,
that's the new brand, right?
That's the new brand. That's
it.
Our swag brand. That's what we're branding all of our stuff. Fast Tracks is still that. Electrician, Electrical Code Academy said, but Electrify is going to be our swag brand. Things like that. Cool.
Electrify.
So tell us, how are things in? Aaron's at it again. Thank you, Aaron. We appreciate that.
Man,
do
look
appreciate
at him
it
already.
So
love
Jay,
that guy, man.
Tell us how things are in Colorado. I'm gonna tell you what, it's getting cold in Texas, so I can only imagine what the temperature is like. Starting to get it like up in Colorado. What is it like? What is the weather? Give us a weather report from Colorado.
So the weather report is in the mornings from the time you wake up. Some of us get up around 5 or 6 to roughly around 9, maybe even a little earlier, roughly about 9 to 10. You're wearing the long sleeve, long johns, the hoodie, the jacket, the heated jacket. Like you're going out to set up. You might Carhartts, because the deal is if you're not prepared going out the door, because you have to go warm up your van, your truck, whatever it is, because, for myself, I don't have a big garage port like yourself, so my truck sits outside, so it's cold in that sucker. So if you're sitting in there waiting for it to warm up, you're sitting there for about 10 minutes, so you better wear your long sleeves, your Carhartts, whatever, and then about 9 or 10 o'clock the sun comes out, and the beautiful state of Colorado just shines, man. But it is getting cold, I can tell you that. The temperature's dropping, all the leaves are off the trees now, so we are officially in the fall season.
In the mornings for us, it's in the 40s. Gets up in the 70s, kind of maybe in the day, but it's Texas, and I love that weather personally. If it was 70 degrees year round, I'd be happy. But anyway, we're getting a little cool as well. Texas is. I'm going to go down to the lake this weekend. I'm going to spend some time.
Good for you.
In fact, I'm off tomorrow, taking off, and I'm going to go down to the lake, and we're going to spend the weekend down at the lake. I don't know if we'll go out on the boat or not, but it don't really matter because we just want to get away. So that's what we're.
So you're taking tomorrow off? Are you taking Monday off as well? Are you doing like a 4-day weekend?
Well, 4-day weekend. I'm going to take
for you.
Friday and Monday off. Yeah.
Attaboy.
Yep. Going to try to
split that up.
Yep. Got to remember what comes first. Mama comes first always. So it'd be a good getaway.
I got my mom I got my mother and
Not my real
dad
mom.
coming
My
in
mama,
on.
mama being my wife, but
Right, I know.
you knew what I was
You
saying.
mean Mama Bear. You mean the boss, the
the
boss lady.
the boss lady.
My actual mother's coming in from Washington State. Got to see her last time I went up to see my sister, and because of my nephew's situation, who he's doing great, just by the way. And I got to follow up because he's finally going in for his first checkup since that incident.
Yeah.
So I got to follow up with him. But since then, I did not see or before then, I hadn't seen my family for a few years. So they get to come down Monday at 6 a.m. in the morning. And I'm keeping my fingers crossed that they get a rental car because I don't want to go to the airport at that time, but I will.
You got to if you got to,
So,
but maybe they'll get a rental.
I got to.
Convince them that they need the freedom while they're down here, so the rental car will give them
Right.
that freedom. And if they get in an argument, you can tell them to just leave.
Well, my dad keeps telling me, he's like, my dad's like, yeah, man, we don't need to plan anything out. We'll just hang out and enjoy Ellie and just kick back and relax. And I'm like, you do not know the chaos that comes on in this house. It's going to take you might enjoy it for about an hour or two, but then you're going to want to take off. You're going to want to go sightseeing or something like that. So, no, we're excited, man. They come down Monday at 6 and then they're going to take off. They're going to enjoy Thanksgiving with us. And then they're going to take off Friday. So I'm really thankful.
Good.
Hey,
That'll be a
thanks
good
guys
time.
for donating, man.
Yeah,
We really appreciate it.
thank y'all. Definitely, most certainly do. We will spin
Chitty
the wheel.
Electric. That's my buddy, man.
And he's down in Anna, Texas, so you're right down. I mean, dude, at the rock throw from here. Holler at me. We'll do a Starbucks or something one day down here, and so yeah, you're real close. That type of thing.
Well, so quick story about Chitty that I found out through Instagram was I did a post the other day, and you and I kind of talked about this. Hey, Tim, thanks for the donation as well. Is I did a little 6-7 minute. Yeah, thanks, Tim.
Jay
post
Preeves,
on
thank
you.
you.
when you become your own boss, people have that concept of I answer to nobody, and I've learned that is not true, man. You answer to everybody, and Chitty was one of the guys who responded to that, and actually he tried to, from what I know, he tried to have his own business twice. And unfortunately, it didn't work out for him. And I still, like I said, I commend him for trying. And also, if it doesn't work for you that time or that second time, it's okay to step down and say, hey, it didn't work, but I'm still gonna go work for someone, give him all I got. Yeah. And he's probably the best right hand man that a guy could have, So
absolutely,
kudos to Chitty, man.
as I tell people all the time, I think you said you had a post and we had talked about it. I know as you posted. Working for yourself is not always, and I guess that's not the topic for tonight's show, but working for yourself is not always everybody's cup of tea, and it doesn't need to be. When people think you work for yourself, that you don't answer to anybody. No, you do. You ultimately answer to your customer. So you do have a boss. You always have a boss, right? And so... and they can be sometimes the nastiest, the customer, because a customer thinks they're always right, and they're not always right. But again, you have to wear with certain types of protective gloves and how you handle the situation. Demetrio, thank you for donating.
Yo, Demetrio,
Schwartzy, thank you, my brother,
it,
for donating. Again, appreciate all y'all doing that. So let's talk about tonight's show a little bit. We're gonna kind of cover a topic that I get a lot of questions about. It has to do with equipotential bonding, and we're just going to have a casual conversation before Jay gets too drunk, and we're going to talk about what is equipotential bonding, swimming pools, why do we do it, and again, swimming pools might not be your thing, but at some time in your career, you might get involved in a swimming pool. So it's important to understand some of these aspects of it, or why we do equipotential bonding. And
yep.
We're talking about grounding and bonding in our webinar series that we're doing for members over on the website, subscribers. It's a different beast because we're trying to reduce voltage gradients between touch points. We're trying to bring everything at the same potential. We're trying to clear overcurrent protected devices. All that kind of stuff in Article 250. That is not what we're trying to do in 680, right? We understand that you're going to have voltage traveling on the earth. You have old utility lines with have a concentric neutral that is not insulated, that's in contact with the earth. You've got potential connections where current's going to, travel through the earth because it is a difference of potential, and that's how current's created. And what's going to happen is you're going to have this traveling on the earth, and you can't get rid of it. But what we do is when we do equipotential bonding, what we're trying to do is mask it. In other words, you don't feel the effects of it, so you're not at a different potential, especially around areas where you could come in contact with it, and it could be a hazardous situation. So we're not removing it. Equipotential bonding is not getting rid of it, but what it is doing is it's trying to reduce the voltage gradients between two touch points, so you don't feel the effects of it. You get me?
Gotcha.
If there's a 500 volt, I'm just using numbers here, 500 volts on this piece of metal, 500 volt and 400 volts on this piece of metal, you come in between them, there's a difference of potential. It's going to travel through you. If they're at the same level, then you don't feel the difference. Okay. Basically it's a masking effect. Easiest way I can, without getting too deep in the show to try to explain that. So that's what we talk about in 680. So we're going to kind of look at what equipotential bonding is. And of course, if you have any questions, you want to shoot them in the chat, please feel free to shoot them in the chat, and more than happy to answer any questions you might have. So what we're also going to do is we will go to the code book. And it will be on the screen. For those that are over in the podcast, obviously you're not going to see the code book. But I encourage you to come on over to either go to Electrician Live. You can watch it live there. Or you can come on over to the YouTube channel. But guess what? You can also watch it in LinkedIn. You can watch it on Twitter. All of them are at Master the NEC, except for LinkedIn. That's at Paul Abernathy. You can watch it on the YouTube. You can watch it on Facebook. However you want to watch it. Feel free to watch, because then you get to see the flavor of something we may share on the screen. But we will do our best to paint the picture audibly so that you get a better understanding of it. Okay. All right. So let me go on and go to the lesson, Jay. So everybody here that sees this, we'll be looking at 680.26. So this is dealing with equipotential bonding. And I probably went a little too far on my screen, so bring it back to where it needs to be here. So this is what we're going to talk about, equipotential bonding. So at a swimming pool, we'll keep it at a swimming pool, but again, if it comes up and we get that far, we'll talk about things like hot tubs and things like that. But let's keep it at a swimming pool to keep it sensible so everybody can understand the concepts of what we're talking about. All right.
Sure.
So performance. So why are we doing equipotential bonding? What's the point? Why are we doing it? Well, equipotential bonding required by this section shall be installed to reduce voltage gradients in the pool area. So from the water to the area surrounding the pool, 3 feet out all the way, or anything that is metal, and we'll cover that is within 5 feet of the pool, we want to reduce the differences of touch potential. Okay, so we want to reduce that voltage gradients from these two touch points. Okay, so we do something. We tie all the metal parts together. We don't necessarily take them back to any panel, although the code doesn't prohibit it. It's just not required. We don't take it to a panel anywhere. It's not to clear an overcurrent device. It's not to do any of that. It is to tie all metal parts around together that's within 5 feet. It's to bond everything, the conductive pool shell, if we've got one, and we'll talk about that. The perimeter bond, there's 3 methods that you can use for that. One of them's garbage, but we still allow it anyway, and I'll talk about that and obviously give my opinion because I do sit on this code panel. But it's like talking to a brick wall when it comes to talking to people about this on the code panel, even though we were presented with evidence that shows there's a better way than the way it's listed in the code. All right, off of my stump, but we'll talk about that too. But that's what we're trying to do. Tie it all together. Okay. So keep it simple when you think about that. Okay. So when you're looking at the code, now I'm going to look at the code because there's no way I'm going to see that's on the screen. So I don't know if folks out there, if you're looking at your phone, there is no way you'd see this on your screen. So the performance, we know what we're talking about when it comes to performance. So now we're going to move into, well, what exactly does all get bonded together? What are we doing around a pool? Okay. Well, we're going to look at 680.26b, and we're talking about bonded parts, Jay. So you've got this pool, okay, and you've got motors that's part of the circulating water. You've got handrails to get down in the pool that might be metal. You have a diving board. The base might be metal. You've got all these things that, maybe a fence that's within 5 feet. That type of thing. So, you have all these metal parts. We're going to start by looking at what the code says about bonding all these parts together, and then we'll break each down, and I'll give you a kind of an idea of what we're talking about for people out there. And some of you might have never messed with pools before. So 680.26b says the parts specified in 680.26b1 through b7, so 7 parts to this that we're dealing with, okay, shall be bonded together using solid. I get that question all the time. They ask and they say, can it be stranded? No. Solid copper conductors, insulated, covered, or bare. Okay, so it doesn't have to be an insulated. That's why you see the bare conductor that goes around the perimeter. We see that 8 gauge bare. We see that. That doesn't have to be insulated. That one's bare. But the wire that would connect all the pieces together would not have to be bare, because those are just connecting components. So you're going to see what's required for something called the perimeter, and then you're going to see what we do with the other pieces that we tie together. Doesn't necessarily mean those pieces that tie the different elements together, that doesn't necessarily have to be bare, right? Still has to be 8 solid, but it doesn't have to be bare. Whereas there are certain rules in here which demand things to be bare. So you'll see that as we cover it. Okay, so it goes on to say not smaller than 8 AWG or with rigid metal conduit of brass or other identified corrosion-resistant metal. Okay, and so that would be an example where you might go down to a wet niche and it comes up to a pool deck box or something, and it's connected with a metal like it says here, it's a rigid metal conduit of brass or other identified corrosion-resistant metal. That might make the bond, right, from down at the wet niche all the way up to the pool deck. So it could be. So, but typically what we're going to see most of the time is 8 gauge solid. Okay. Also remember, you could go larger, but why? Why would you go? Why would you go larger? You don't have to go larger. Okay, so it says connections to bonded parts shall be made in accordance with 250.8. So 250.8 is that list of acceptable methods to make the bond. Okay, acceptable methods to do that. Okay, so you have a list there in 250.8. That's where you're going to see things like wire binding devices, compression lugs, all these type. You'll see a list of stuff. Okay, it says an 8 AWG or larger solid copper bonding conductor provided to reduce voltage gradients in the pool area shall not be required. Now check this out now. Shall not be required to be extended or attached to remote panel boards, service equipment, or electrodes. So it's not there to dissipate lightning. It's not there to trip an overcurrent device. It is only there, and you're only tying these pieces together. And if you keep that in your mind, you're only doing this to reduce voltage gradients amongst touch points. Okay. But you'll notice that it says it's not required to extend or take back to the panel. You could, but again, you're not required to do that. And I would personally recommend that you don't do it. Okay.
Right.
So anyway, so it's there for its specific need. Right. All right. So then you've got your 7 elements that we have to deal with. Okay, so the first one is, a conductive pool shell. What's a conductive pool shell, Jay? So if I have a swimming pool and it's like a gunite, which you have rebar and it blows the gunite on it, kind of a concrete mixture, then the rebar is making up the conductive pool shell in association with the concrete. Okay, it's not just the rebar, in association with the concrete. If that rebar is encapsulated, means it has a coating on it, then guess what? It is not a conductive pool shell. That type of thing, because it's encapsulated. All right? So let me read a little bit of what it says here, and you'll see all the little pieces. I know Robert asked, why don't you take it to the panel? Because there's no need to take it to the panel. It's trying to create and reduce voltage gradients. It doesn't need to go to the panel. What breaker are you trying to trip? This is for voltage gradients. It's not. All of the equipment, like motors and whatnot, that's going to have an equipment grounding conductor. That is going to be what trips the breakers. So you don't take it to the panel because there's no need to take it to the panel. You're not trying to trip a breaker.
Right.
All you're doing is trying to tie metal parts together. And so that they're all at the same potential. So if
which is kind of nice.
Yep.
Because sometimes a panel isn't.
Yeah, but hold on. Let me make James understand here. You're getting lost here, James. It doesn't matter that the panel's metal. It could be somewhere else on the property. It's already connected to the equipment ground for it to trip. It's touch potential. So we're talking about when I'm right beside the pool and I'm within 5 feet of the pool, that panel is not going to be within 5 feet of the pool. So there's no touch potential there. Remember, this is all about touch potential. It's not about clearing a breaker. Has absolutely nothing to do with an overcurrent device at all. Nothing to do with it. There's no need to take it back to a panel.
When you say touch potential, you mean by like individuals in the pool, any part of that pool, any part within 5 feet that a person can kind of come into contact, whether it's a child, whether it's adult, whether it's a teenager. That's what you mean by touch point, right? Like an individual person touching something.
Yeah. Touch potential between me being able to touch two pieces of metal and then being at the same potential. So I don't have one at a different potential, because when you have them at different potentials, that's how current flows. Okay. It's the voltage. The voltage doesn't kill you. The current's what kills you. Right. So again, that's what we're doing. Now, in his example, if you have a motor, if that motor is part of the water circulation, then that has to be connected to the equipotential bonding grid. So the motor gets connected to it because it's associated with the circulation of the actual water. But the panel itself, that is different. That's going to have equipment grounds in it. That's going to be all those type of things. And you're going to see here later, James, where it's all about proximity. That's the key. All about proximity.
Yeah.
So what we don't want to confuse equipotential with anything to do with bonding of gas lines or bonding of has nothing to do with any of that. This is all about equipotential. Okay. All right. So let's look at it. So what's a conductive pull shell? It says bonding to conductive pull shells shall be provided as specified in 680.26B1A or B1B. So we got two options here, right? And it says, cast in place concrete, okay, pneumatically applied or sprayed concrete. That's like a gunite type of, pumping that bad boy out there. And concrete block with painted or plaster coating shall be considered conductive material due to water permeability and porosity. So, if I have a pool that is made of cinder block, is that one of the options here? Concrete block, we should say concrete block. Concrete block, whether it's painted or plastered, guess what? It's still considered a conductive pool shell. All right. If it's rebar and it's sprayed, then, with it, and it's got concrete and all that, concrete is still a conductive pull shell. Okay. All those type of things. Let's see. So other people say, well, no, it's painted. It's maybe it's concrete block. It's the old cinder block style or whatnot, but they painted it. Doesn't matter. It's still considered porous. It still can absorb water, and it is a conductive pool shell. Okay. All right. So what is not a conductive pool shell? Just so we can get that out of the way right off the bat. What is not? Well, vinyl liners. So a vinyl liner pool, it's not a conductive pool shell, right? So that's that's there. And it says a fiberglass composition shell or composite shell. So you get those fiberglass ones, and you dump them in the ground. The ones that people report float up when the groundwater swells or something like that. I've never seen that happen, but I could see where that might happen if you didn't install it right. So a fiberglass shall be considered to be non-conductive materials. Okay. So what that means is that If that's the case, it's not considered a conductive pool shell. All right. So let's establish that we have a conductive pool shell. Okay. Then it goes on. You remember it says it applies to B1A or B1 or B1B. So what's B1A say you got to do? Okay. It says structural reinforcing steel. Now listen, it says unencapsulated structural reinforcing steel shall be bonded together by steel tie wires or the equivalent. So basically they hand tie the rebar together as they make up the frame. You know what I'm saying? It says,
right,
where a structural reinforcing steel is encapsulated in a non-conductive compound, a copper conductor grid shall be installed in accordance with 680.26B1B. Okay, so this brings us back to the interesting point. If it was concrete encased, or if it was encapsulated rebar in the gunite would qualify as a conductive pool shell, even with the rebar is encapsulated. So what this is saying is, look, if that rebar is encapsulated, right? If it's encapsulated, then, you wouldn't need to. If it was regular rebar and it was in the concrete, then you're good, right? For the shell, right? And you're required to do this. You're required to do this shell. But since you have encapsulated rebar in that concrete, that gunite that you're spraying, it's encapsulated. It means it's the metal has a coating on it that's non-conductive. Then you got to go to B. And what's B option? Well, B says, okay, it says you're going to put a copper conductor grid. It says a copper conductor grid shall be provided and shall comply with the following. Constructive of a minimum of 8 AWG bare solid copper conductor bonded to each other at the point or crossing in accordance with 250.8. So you're going to use the right type of connection between these points. Okay. Or other approved means. You're going to conform to the contour of the pool. So check this out. If it's a concrete pool, and it's got metal rebar in there, it's going to make up the frame of the pool, right? The whole frame is made of the rebar, right? Then that's a conductive pool shell. If it's encapsulated, you still got the concrete. So it's still a conductive pool shell. But now it's saying, well, because it's an encapsulated rebar, guess what you got to do, Jay? You have to put a concrete, for lack of a better example, a concrete mesh underneath the entire surface of the pool up to the sides. Basically, basically you're setting the pool in a blanket of copper grid, if you will.
Gotcha.
Which, by the way, at the price of copper, probably ain't nobody going to do that. So they're going to use rebar in there if that's the kind. So it's probably going to be non-encapsulated rebar most of the time, right?
Yep.
So if you did do the copper grid, and our company makes copper, yay copper. If you do the grid, then it has to be arranged in a 12 by 12 inches. So we have to have 12 by 12 grid. So this is a big grid of 12 by 12 squares. Okay. And you got a tolerance of 4 inches. So again, it's still going to try to keep it at the 12 by 12. And it's to be secured within or under the pool, no more than 6 inches from the outer contour of the pool shell. So it's kept either in the pool contour or no more than 6 inches outside of the pool contour. So basically, you'd have to put the grid down. Then you would have to put the rebar in as it was encapsulated, and you're spraying the gunite. You'd have to put the copper, 12 by 12 grid down. Nobody's going to do that. Most of the people I know, they're just going to use rebar because they're going to spray it and encapsulate it anyway. And that's just what's going to happen. Now, will water permeate into that gunite and all that stuff? Yes. Over time, it is porous. It will get in. And that is where you've ever seen on some of those shows where they go and dig up old pools and stuff. You ever notice that the rebar is rusted a little bit and all that? It's because it's an old pool. But to be honest with you, most of the rebar that's inside of the concrete like that is going to outlast me or you, except for the fact that it cracks and gunite cracks and then it leaks and water gets through it and then it doesn't hold water. Then it's got to be resurfaced and all that kind of stuff. Okay. So personally, go with the fiberglass pool. So anyway, but gunite looks nice. They like it. Okay. So that's a conductive pool shell. Remember, If it's vinyl or fiberglass, then you got to do nothing. You can skip number 1. You don't do anything. Okay? You with me?
Yep.
All right, so now we're moved. That's number 1. So number 2 is, okay, we covered the pool. What about the area around the pool? This is called the perimeter. So perimeter surfaces. So B2 says the perimeter surface to be bonded shall be considered to extend 3 feet horizontally beyond the inside wall of the pool, and shall include unpaved surfaces. So that means even the ground. It doesn't have to be paved, pavers, blocks, concrete pour, whatever. So again, it's all surfaces, unpaved or paved. So yes, that would mean that when we get to what the allowances are for the perimeter, it would mean putting your option in the ground, around the pool, even if you didn't have pavers or hardscape around it. Still got to run the perimeter. Okay. And it says, let's see here, including unpaved surfaces and other types of paving, perimeter surfaces separated from the pool by a permanent wall or building 5 feet in height or more shall require equipotential bonding only on the pool side of the permanent wall or building. Okay. So if you have a hardscape, a hard wall or something on the side of it, you only have to do it up to that wall. Okay.
Gotcha.
All right. So then it goes on to say bonding to perimeter surfaces shall be provided as specified in 680.26B2A, B2B, or B2C, and shall be attached to the pool reinforcing steel. Okay. Remember, if it's a conductive pool shell, it has to be connected to either the reinforcing steel, which is inherent in the construction, unless it's, of course, it's encapsulated. If it's encapsulated, then it says you connect it to the copper conductor grid that we had to do underneath the pool because it was what? Encapsulated rebar. You with me?
Right.
Okay.
Yep.
Now, the important thing to remember here is even for this perimeter, if it was a vinyl or fiberglass, you still got to do the perimeter. You just don't connect it to the conductive pool shell because guess what? There is no conductive pool shell.
Yeah,
it wasn't required.
Sure.
Because it was vinyl or fiberglass. Okay. So anyway, it goes on and says at a minimum of 4 points. So if you take the pool, now let's say for argument's sake, we have a normal swimming pool with rebar and they blow in gunite. And so it is a conductive pool shell. The rebar turns up and at 4 corners, you're going to connect the perimeter to those 4 corners. They're going to connect it to the perimeter, which follows the contour of the pool. And it's going to go out 3 feet, right? So now It tells us 4 points uniformly spaced around the perimeter of the pool. And it says here, again, the very last sentence, for non-conductive pool shells, bonding at the 4 point shall not be required. What are you going to bond it to? There's no bonding. There's no conductive shell. So There's nothing to bond it to. Okay. But it does still require the perimeter. Okay. Because you do have a touch potential that you could gain from when you walk out of the water and you step on that surface immediately adjacent to the water, 3 feet around. Okay. So you could have difference of potential because you got voltage that's traveling on the earth and you've got this big, for the lack of a better term, big old electrode, which it doesn't qualify as electrode, by the way, in the ground, concrete and steel. It's going to have voltage that's going to come onto it through these concentric neutrals and utility systems because they frankly don't care, and it's acceptable. And so it could be a difference from the water to the point where you step at the surface. And remember, that's why we're bonding it all together. But don't worry because we're going to have to bond the water too. So we're good to go with all those touch potentials, right? Okay. So let's look at how you can do it. So you have 3 options here for this perimeter. So the first one says, well, you know what? If you did have like an old gunite pool with the reinforced rebar and you bring it up and you turn it over the edge and you extend that out 3 feet, well, that's perfect. It says structural reinforcing steel. The structural reinforcing steel shall be bonded in accordance with 680.26B1A. Okay. All right. So that could be your rebar. The other thing that people tend to not understand is it also could be like the metal mesh that's utilized as structural reinforcing steel in the decking material. So a lot of people will use the metal steel that they roll out like a fencing, and that adds reinforcement to the decking. Could also qualify for that. Some places say, nope, we're not going to let you do that. But I'll just remind you, it says structural reinforcing steel. It doesn't say that it has to be the component of the conductive pull shell. So it could be just a metal like the heavy gauge fencing that's rolled around it, that type of thing. And it would be connected to the conductive pull shell if that's what you have at the 4 points, 4 corners, right? If that's what you have. So that's the first one. So it could either be the rebar turned out, right? Or it could be, again, the reinforcing steel mesh. And people don't like for me to say that, but we talked about it. I'm on that code panel. We know that it's permitted. We're not going to discuss it deeper at the panel, but we know that it's permitted. People do it all the time. Okay. Now, the most common with that, though, usually is the rebar ends up being carried over, and they carry that out all around the perimeter of the pool, and that's what they get away with. All right. The next one is probably the most common one we see, right? And this one, and I probably should, hold on, I know that people are looking over on the stream and saying, Paul, you need to scroll down because we're at perimeter. Sorry about that. So the next one that we're looking at is called the copper ring. Okay, so the copper ring is where you run an 8-gauge bear, so this is the bear, around the entire perimeter of the pool, all the way around, right? And it has to be located specifically between 18 inches and 24 inches, okay, from the inside wall of the pool, very specific, right? It follows the contour of the pool, okay? It's required conductor shall be secured within or under the perimeter surface, so it can be in it or under it, okay? So perimeter surface, 4 to 6 inches below the subgrade. Now, people argue all the time what the subgrade is, but you've got the top finished grade. Subgrade would be underneath it. So once you get underneath the top grade, that's called the subgrade. You have finished grade, and then anything below that would be subgrade. Okay, so that tells you that even if it was grass around your pool, Jay, you're still going to install. If you want to do the ring method, you're still going to install it in the ground. Okay, around the pool. Now, if you do have a conductive pool shell, what did we say you got to do? You have to connect at equal spacing at 4 points around the pool. You would have to connect over from a conductive pool shell to this 8-gauge bear that runs around the perimeter. You with me? Okay. Yep. So that is what you would do if you want to, and that's probably the most common perimeter bond that people do. The problem with that is, and I won't get on my stump, but the problem with that is we're looking for deaths in bodies, and people say, well, it seems to be working because people aren't dying. Well, when the study was actually done and it was presented to the code panel, they presented the fact that chances are that single 8-gauge running around probably wouldn't work. But because, we don't have the body count, but the testing it was done showed that the next method was actually the best method. Okay. And the best method was called a copper grid. Now they wouldn't agree to get rid of the single wire, but we agreed to add the grid, knowing that nobody's going to pay for the grid because of the cost of copper. Nobody's going to use this option. So you can actually buy this in a roll. Okay. And you can get it 3 feet wide, and it will actually can roll this copper grid around the perimeter of your pool, right? And it's probably the best method for creating a perimeter, equipotential bonding for the perimeter surface that there is. Just shy of the rebar works fine too. I will tell you the wire mesh, okay, like fencing mesh, that does work fairly well as well, and that's the cheapest method to go. Okay, cheapest method. Rebar, it's just inherent in the construction. So if you could get them to turn it out for the decking, that works great as well. But a lot of people do the single copper wire around the perimeter. Okay. That type of thing. I have no idea, Jay. Again, what just happened to your little box? Something happened and your little dude just went itty bitty. You got itty bitty on me.
Uh-oh.
So I got to draw you back out here because I don't know what's going on with that. Okay. So if they want to do the copper grid, it says where structural reinforcing steel is not available or is encapsulated in the non-conductive compound, copper grid shall be utilized where the following requirements are met. Okay, so this gives you options to do the copper grid as well. But most people are going to do the ring. It's probably what they're going to do the most. Okay?
Right.
All right. So we established the perimeter. Okay? All right. Now, after that, the next thing we go to is the third element. Third element says metallic components. Okay? So this is 680.26b3. It says all metallic parts of the pool structure, including reinforcing metal not addressed in 680.26b1a. Okay? So B1A was the structural reinforcing steel. It says shall be bonded. Where reinforcing steel is encapsulated with the non-conductive compound, the reinforcing steel shall not be required to be bonded. So when you have rebar that is encapsulated, it is not required to be bonded. Okay, it's encapsulated. And we have all these other rules that you have to follow. If it's encapsulated, but it's in concrete and it's a conductive pool shell, then you got to put the copper grid under it and all this kind of stuff, right? So this is just saying that any other metal component has to be all bonded together, okay? So any reinforcing metal that is not part of the conductive pool shell would still all have to be bonded together, right? You with me?
Yep.
Okay. So the next is 4. Underwater lighting. It says all metal forming shells and mounting brackets of no niche luminaires shall be bonded. So your wet niche mounts in your framing of your pool shell, and typically we will bond to it and take it up to and connect it to the perimeter, or connect it to all the pieces together that make up the equipotential bonding grid, tying everything together. Okay. Also, if you have a no niche luminaire, which is exactly how it sounds, it mounts on the wall and there's no niche associated with it. But you still have a frame for it. You still have a mounting hardware, right?
Mm-hmm.
So you're going to have to, any of the mounting brackets, you're going to make a connection on it. Usually it has a lug on it, and you'll take that, and that gets connected to all the pieces together. You're just tying them together for the equipotential bonding grid. You with me? Okay.
Yep.
All right. It does have an exception. It says listed low voltage lighting systems with non-metallic forming shells shall not be required to be bonded. Obviously, if they're low voltage and they're also non-conductive, there's no real need to tie to those things. So the next one is B5, which is metal fittings. It says all metal fittings within or attached to the pool structure shall be bonded. So again, that would be all fittings. All fittings that attach it. Then it goes on to say, look, isolated parts that are not over 4 inches in any direction. So these are little components, little pieces that are not over 4 inches in any direction and do not penetrate into the pool structure more than 1 inch shall not require bonding. So you're getting a little bit of relief on small little components. Okay. Next, it says, and this is new for 2020, it says next, metallic pool cover anchors. Usually these are anchors that are mounted in the decking system, and they're obviously going to be within 5 feet, right? Okay, somebody's telling me to scroll. Sorry. There we go. See, I keep an eye on, I try to keep an eye on stuff. All right, so in 5, it says the metal fitting says metal pool cover anchors intended for insertion in a concrete or masonry deck surface 1 inch or less in any dimension and 2 inches or less in length and metallic pool cover anchors intended for insertion into wood or composite decking surface 2 inches or less in any flange dimension and 2 inches or less in length shall not require bonding. So the point here is I am not going to think about trying to run this 8 gauge and freaking go all over the deck trying to bond these little pieces of metal parts. So if it is isolated parts around the pool that are not over 4 inches, then I don't need to bond them. If it's pool anchors for pool covers, and I'm sure you've seen them, they actually get installed around the pool and the cover goes on it and they have little springs on them. So it gives, and they'll be mounted all around the pool. Some of them are going to be anchors that are recessed down in the concrete. Some are wood decking. They'll be recessed into it. If it meets these dimensions, and most of the manufacturers know this by now that produce these pool anchors, and they're like, dude, we're not going to make things difficult for you. We'll make sure they meet these dimensions. Okay. But that's not to say that some ragtag person or whatever goes and tries to create their own. And if they don't meet these dimensions, then yes, you would have to bond these things. And don't ask me how you would do it, how you would get lugs on it or whatnot. You know, better off follow the code so you don't have to do that. Okay. So that's those little metal fittings. All right. Next one is B6. Now, B6 it says it as it says it, general. It says electrical equipment. It says metal parts of electrical equipment associated with the pool water circulating system, including the pool pump motors, metal parts of the equipment associated with pool covers. That's, again, maybe the motor that's going to retract the cover or things like that, including electric motors, shall be bonded. Right? So most of these motors will come with a lug on it, right? Right there on the frame for you to be able to do this. It is not a direct connection with any equipment grounding conductor that's actually run with the branch circuit that's going to the motor, into the motor housing shell. Okay. It probably indirectly, obviously, is going to be together, but it wasn't a direct connection, but it began due to the nature of how it's installed. So, again, not a need to you to take anything back to the panel because indirectly your equipment ground for that motor is actually going back to the panel, right? So it would be any electric equipment, okay? Any. I don't, we can add controller and all that, but it's any electrical equipment. But it says metal parts of electrical equipment associated with the pool water circulating system, okay? Included pool pump motors and metal parts of equipment associated with pool covers, including electric motors, shall be bonded. Now, there is an exception here. Says metal parts of listed equipment incorporating an approved system of double insulation shall not be bonded. Okay. So if it's a double insulated pool pump motor, then it doesn't need to be bonded. Okay. So again, if you're using the exception to this rule. Now, when you look at it, it's broken into an A and a B here. Notice when it says there's something you have to do here. So when you have a double insulated water pump motor, it says where the double insulated water pump motor is installed under the provisions of this rule. Okay, so you remember what we said? It doesn't need to be bonded if it's double insulated motor, right?
Mm-hmm.
So now let's assume that we chose a double insulated motor. It's telling me that the double insulated motor is installed under this provision rule. It says a solid 8 AWG copper conductor of sufficient length to make a bonding connection to a replacement motor shall be extended from the swimming pool equipotential bonding means to an accessible point in the vicinity of the pool pump motor. So let me stop it right there. So it's telling you that if it's a double insulated pump, you do not connect it to the equipotential bonding grid. However, they do want you to run that 8 gauge over to the location where the pump would be, because somebody could come and replace that double insulated pool pump motor with one that is not double insulated. And guess what? Now they need to make that connection to the equipotential bonding grid. You with me? So the code is going to say, yeah, I get it. You're not required to do it because it's double insulated. But you know what? Go on and run that 8 gauge over there anyway. All right? So that's what it's saying. Now, it says, where there is no connection between the swimming pool equipotential bonding means and the equipment grounding system for the premise, this bonding conductor shall be connected to the equipment grounding conductor of the motor circuit. Okay? So people ask all the time, what are you supposed to do with it? Then you connect it to the equipment grounding conductor of the motor. Okay.
Okay.
All right. Let's see here. And that is it. Probably, I don't know why it requires that. But again, if it's double insulated and you're not making that connection, it's telling you got to do something with that 8. So it's telling you to actually connect it to the equipment grounding conductor of the motor circuit. Okay. So next one is pool water heaters. It says a pool water heater rated at more than 50 amperes and having a specific instructions regarding bonding and grounding. Only those parts designated to be bonded shall be bonded, and only those parts designated to be grounded shall be grounded. So a portion of it connected to, let's say, the grounding of the equipment grounding conductor, and only portions of it where it's marked on it or says for bonding or has a bonding symbol, that's where you're going to connect the bonding if it's going to be connected to the equipotential bonding grid, okay? Not where the equipment grounding would be, that type of scenario. And then, of course, the last one, and then we'll get into some other nuances, but I just want to cover these real quick before we go deeper in it, and I don't know how we're doing on time. All right, so number 7 is
7:50.
Okay, yeah, we might go over now.
Doing good.
So fixed metal parts. Oh, so this is the one where it tends to drive people crazy when it comes to the bonding around the pool. It says all fixed metal parts shall be bonded, including but not limited to. So this isn't an all-inclusive list here. To metallic sheath cables and raceways, metal piping, metal awnings, metal fences, and metal doors and window frames. Okay. Now, these are to be bonded to the equipotential bonding grid. So yes, if I have a metal frame, okay, and it is within 5 feet, then I'm going to actually bond it. Okay. And I'm going to bond it to the equipotential bonding grid. Now, a lot of people think that is for anything like, I've had people say, well, you know what, that's because somebody could run an extension cord through the window frame or through the door and it energizes the metal parts. That is not what we're doing. Again, we're not trying to clear a breaker. We're trying to reduce voltage gradients. Okay? So that's why we're connecting these pieces together. So again, you have touch potential between points. Now, you do have some exceptions to this rule, but this would mean if I had gutters, if I had metal fencing, if I had posts, metal posts, all those type of things, then that would be an issue where we're going to have to make sure that we make that connection. Now, there is 3 exceptions. So let's read the exceptions to this. And again, this is to bond those metal parts, fixed metal parts. Again, fixed metal parts. Number 1, those separated from the pool by a permanent barrier that prevents contact by a person shall not be required to be bonded. Okay, well, dude, if it's behind a wall and you can't get to it, then there's no sense in bonding it, right? Now, the only problem with exception number 1 is we don't give a height requirement on that. So, we should say a certain height, and I can't remember if we fixed that in 2023 or not, but we should say a height or dimension, but we really don't. So it's basically saying those separated from the pool by a permanent barrier, we don't give a height on that prevent contact by a person shall not be required to be bonded. Okay? So that's that. So that's fixed metal parts that are behind the barrier. We don't say the height and all this thing, but we're going to assume that it's of substantialness that we can't reach it. Let's assume that. Exception number 2, those greater than 5 feet horizontally from the inside wall of the pool shall not be required to be bonding. So anything outside of that 5 feet, it's not required to be bonding if it's fixed metal parts. Okay. And then number 3, it says those that are greater, and again, when it says those, we're talking about those fixed metal parts, by the way. It says those that are greater than 12 feet measured vertically above the maximum water level of the pool, or as measured vertically above any observation stands, towers, or platforms, or any diving structure shall not be required to be bonded. Okay, so it's of sufficient height that there's unreasonable to have to try to bond it. Okay, because you're not going to have this touch potential between the water and it because of, again, the proximity and how high it is. So distance plays a role in this. So, and since it's horizontally, that tells you that anything within 5 feet again, would all have to be bonded again to the fixed metal parts. You with me?
Yep.
You get me? You feel me?
We're tracking.
Okay. All right. So let's see. So then let's, the last one, and we'll just talk about some different things, why you might want to do what you want to do. But lastly, let's talk about the pool water. So pool water, it says, where none of the bonding parts are in direct contact with the pool water, the pool water shall be in direct contact with an approved corrosion resistance conductive surface that exposes not less than 9 square inches of surface area to the pool's water at all times. The conductive surface shall be located where it is not exposed to physical damage or dislodgement during usual pool activities. It shall be bonded in accordance with 680.26b. Okay, we have to bond the pool water. If your pool is a conductive pool shell, it already is part of, it already qualifies as a conductive surface, and it follows 680.26b1, then you ain't got to do jack. It's already bonded.
Right.
Because the pool conductive shell is bonded, and that's one of the elements of 680.26b. So you don't do nothing. Right?
Nothing.
Yep. Now, if it's a vinyl pool, if it's a fiberglass pool, and you have to bond the water, so you can do it through a metal rail. If the bonding connection if it's a metal rail that goes down into it, obviously it's within 5 feet and it's a fixed metal part, you're going to have to bond it anyway, right? So if it's got enough surface area, the 9 square inches, then guess what? It qualifies. Okay?
Very good.
So tell me, James, you tell me, you're a pool expert. You tell me where you disagree with what I just said, because I see the eyes rolling there. Tell me where you disagree so I can explain where you're wrong. All right, so the next, if there are other ways to bond the pool water, if it was fiberglass and it was a non-conductive rail and your ladders were non-conductive, plastic or whatever, or encapsulated or coated, then you could put a device that's located in the water circulating system. You could put it in a skimmer. You could actually, they make the ones that actually, it's like a metal, it's a coil, copper, that actually goes in the water. You know what I mean? So it's part of the circulating system. So we're bonding the water. So with that said, if people ask me, what is the deal with bonding the water? Okay. And I'm going to give you my theory on it. And when I was at NEMA, I brought this up, and it was a friend of mine, NFPA, a good friend, Jeff Sargent with NFPA, said, I don't know that that's 100% accurate. And I said, well, I'm telling you what the manufacturers told me in a discussion that we had with the manufacturers. So let me give you this concept. Any receptacle that's within 6 feet of the pool has to be what? GFCI protected, right?
Yep.
Okay. So if I have pool water that's not bonded, and it's in a fiberglass pool, let's say, so it's just pool water, and I'm not bonding it, and I go out to my pool, and I want to lay out my thong, and you'll picture that, and I'm out there, in my what do you call it?
Hammock.
Banana hammock, and I'm laying there. I know everybody out there is going, really? You got that visual now? And I'm out there, and I drop my radio in the water. So think about this. Due to the gradients in the water, what happens is, probably that radio is probably going to be a non-polarized plug. I mean, probably just going to be a two-prong, right? And it's going to go into the water. So what's going to happen is, in that short distance, it's going to complete the path. And the GFCI might not activate right away because there's no return path or no way for current to get out of there, okay? Now, over time, there's enough gradients in that water that it might happen. But in reality, the water can become energized, and it wouldn't necessarily clear a GFCI. Now, people say, well, Paul, I don't know if I agree with that. Well, let me ask you a question. Would you agree that if you touch the positive, the hot side and the negative side on a GFCI, that it will not shock you? That it will not activate a GFCI because it treats you like a load and it doesn't find another path to leave. The moment that you touch something else and give another path for a return path or a grounded surface, guess what happens? That GFCI trips, right? So if I have a radio and I drop it in the water and there's no way for it to return, so the currents coming out of it is going on the black and coming back on the white, depending on the water's makeup or what's in it, it might not trip a GFCI right away. You with me?
Yep.
Okay. Now, if I actually bond the water and I give it another path for current to flow, and remember, current always flows on all available paths back to the source. The source is the utility, right? So you'll have some of that current that will travel through the metal parts that are bonding the water through the earth. Not a lot, but enough to create another path for current to flow. Then a GFCI can sense that, and it will detect that current is flowing in an unintended path, and the GFCI will function quickly. Make sense? If you do not give it another path for current to flow, then you make it harder. You make it harder for the GFCI to function. Now, I just happen to also believe that if I'm in the water and the radio falls in because somebody does what they do, and current travels through the water, and I am in fresh water, I will be at a greater difference of potential than the water because of our salt makeup. It's different in salt water than it is in fresh water. Most of the deaths that come in water incidents with electric shock is not from electrocution, it's from drowning, and that's in fresh water. Salt water, there's enough voltage gradients because of the salt water in you, the salt makeup in you and the salt in the water, that there's not that great a difference of potential, and it doesn't affect you as much. However, in fresh water, there is a huge difference between you and the fresh water. So it creates a voltage gradient, and that causes your inner ear. You get discombobulated, and you end up drowning. Most people do not get electrocuted in the water. They drown, and that's because they either seize up or lock up, and they don't have muscle control, and they end up drowning. It's not so much they get electrocuted, right? More deaths happen in fresh water than salt water when it comes to that scenario because of voltage gradients in salt water because of the salt, okay? And we're made up of a large amount of salt. Fresh water, it's totally different. So when the manufacturers told me during a meeting, they said, in order for the GFCIs to function, the bonding of the water allows for us to give another path back. Now, that wasn't the intended purpose of it. The intended purpose of it is reduce voltage gradients from leaving the water and stepping into the perimeter surface, right? You don't have two differences of potential, right? Or if you're in the water, in the pool, and you reach out to something that's on the deck, right? We don't want to have differences of potential. But a byproduct of that is, I believe, wholeheartedly, that it allows for a potential GFCI to function quicker and more reliable. Some people disagree with that, and that's perfectly fine. But if you think about the concept of how they work, then it makes sense for that. Okay. Anywho, just to kind of the history. So you gotta bond the water. Just remember, like I said, if it's already a conductive pool shell, right, then you don't have to do anything. You don't have to bond the water because it's already bonded. You know what I'm saying?
Yep.
It's already done.
It's already bonded.
Already bonded. So I'm trying to look, and I don't know what happened to my chats. Disappeared on the other one. So I can't, I'm trying to, there we go. They're coming back now. It says, James says we do rebar and do all the bonding and still require to add the water bond. You have an excellent point. Never thought of it. Yeah. So the thing about it is the B1, 2, 3, 4, 5, all of those are conductive components that tie everything together. So when you read the pool water, it says, it shall be bonded in accordance with 680.26b. It doesn't start at 2 or 3 or 4. It starts at B. So if we're here to say that concrete, whether it's painted or plastered or it's gunite with rebar, that is a conductive pool shell. That is, and we already say in the beginning that that's porous, that it absorbs water. Then guess what?
Right.
There is way more than 9 square inches of surface to it. So bonding of the water with another means is unnecessary. That type of thing. Okay. So it's pointless, to do it. You got one big pool that is a conductive. The whole thing is way more than 9 square inches.
Right.
So, All right, so that's the nature of the conductive pull shell. And that's the nature of bonding all the pieces together. So the easiest way I explain this to people is this. If you have all these things within 5 feet, they're fixed metal parts, they're all anything that's metal, okay, that is within 5 feet of the inside edge of the pool, you're going to have to bond it to that equipotential bonding grid. It does not have to go back to the panel, but you tie everything together. Now, here's the next question people ask. Do I have to daisy chain it all? And the answer to that is absolutely not. You could do the equipotential bonding for the perimeter, and then you could take a single line, a bonding conductor over to the motor. You could take another one and tap it onto the perimeter bond if you're going to use the 8 around the perimeter, if that's what you're going to use. And I can run over to the pool heater. I could run over from the 8 gauge around the perimeter. I could take a bonding jumper and take it over to the ladder if it's a metal ladder. Okay, it doesn't have to loop. It can do what's called a star pattern if you want. Okay, it does not have to be just looping through everything because all you're doing is tying them all together. Now, here's the other thing that people lose sight of, and it's probably not a big deal, but you only has to be bare where it tells you it's bare. So when I'm going from the perimeter 8 gauge around the perimeter that has to be bare, or the grid that has to be bare, but I'm going to go over and connect to a motor, that doesn't have to be bare. Still got to be 8 gauge, but it could be insulated if you want. Because all we're doing is tying it together, that type of thing.
Right.
We're not utilizing the contact with the earth like we are with the perimeter grid or with the bare around it. We're just tying that motor to this grid. We're tying that diving board metal base to this grid. We're tying that ladder to this grid. That's all we're doing, okay? And then people say, well, what about the drains and all those type of things, right? Then at the end of the day, if they're pieces that are not more than 4 inches, then they don't have to be bonded, right? So you don't have to connect to it, those type of things. Make sense? All right, so
yes,
that's kind of the quick and skinny. And I'm going to tell you what, if you're really interested in learning about pools and spas and everything about 680, not just the surface that I covered, kind of touching it, barely tapping it, over in our membership area, whereas we have our monthly membership, we have an 8-part series on swimming pools where I had a guest come into the studio, and it was Vince Delacroce, and he's with Siemens. He's a good friend of mine.
Guy.
He's on Code Panel 17 with me. We do a long series on swimming pools where we go into part 1, part 2, part 3, part 4. Again, we talk about that for the hot tubs and whatnot. We go into everything, and it's right there. So it's available. So it's $9.99 a month if you want to get it. That's worth the price of admission in itself because it's a full 8-part series. But check that out over on our website. Again, electrocodecademy.net. You'll see subscription in there. Boom, you get it. You can cancel it anytime, or you can buy the annual and you pay one fee and you get it, that type of thing. Okay.
Yeah, I put a link on it earlier up top too. If you scroll up, so
cool. Yep, man. Vince is an awesome guy, and I love when I get a chance to get with Vince. That type of thing. He's a cool dude, and he brings insight from Siemens, and just a cool dude all around. So I don't get to see him enough. And since I don't really support IAEI anymore, I mean, nothing against them, but I really don't. I don't get to go down there because he did invite me to go down there to Florida and teach some classes like I always do, but I declined to do that type of thing. So it's kind of I feel bad that I did, but it is what it is. All right, so let's go on to the code turd. Boom. Okay, we're at the code turd of the week. This is real simple, right? This Jay? I don't know. Oh, Jay, it did it again on your little video here. Let me get you. I don't know what's going on with you. Why it makes you a little mini me. It makes Jay the mini me.
I'm tiny.
Mini me. So here it's on the line side or supply side. So I'm assuming, so this isn't a tap. It has no tap rules associated with this. But basically it looks like it is a sheetrock screw screwed into one of the phases, and then they wrap a conductor around it. So they needed a little extra power. So that's what they kind of just made a supply side connection. I can promise you that is not a connection that's listed. in the National Electrical Code as acceptable method to make this connection.
You know where that line's going, right? That's going to someone's grow room.
Is that what it is?
They're growing the stuff. They're growing that mile high stuff, and they just tap power to do it. So
that little one. Well, let me tell you what. If they're doing grow lights, then chances are that looks like a 12 gauge. I probably doubt they're going to be hitting some grow lights with that little 12 gauge. So I have had people contact
all you need
me.
Is one.
Huh? All you need is one grow light?
Sometimes all you need is just one light. You know, just a little. They're just doing a single one. You know,
just one plant. Okay.
Anywho's,
sounds like in Colorado. It sounds like you're talking from experience. So anyway, I don't know. We want to see what's in Jay's back room. He keeps talking about this warehouse. I don't know, man. Chances are he's got this big grow outfit going on. So anyway, don't do this. And I just can't imagine somebody would go and try to do this. And even if this was on the load side, obviously this is an acceptable method to tap a conductor. And again, since this is on the supply side, you are allowed to make connections on the supply side to the service entrance conductors. But this is not an acceptable way to do it. Okay? It is not acceptable.
Rombo says it works.
It works. No, Rombo,
Rombo's
get that out of your head. Just because something works doesn't make it right, because at some point it's going to fail and we're going to be blaming somebody. You know what I'm saying? So this is when people do this. There is no way that an electrician did this. I refuse to even stoop as low to our trade is to think that there's an electrician out there that would do something like that. Okay? If they are, they need to get out of the trade. Go somewhere else. He said that looks safe. Okay. Yeah, it does, doesn't it? That looks safe. So let me ask you a question. Hey, here's a good one for you, everybody. So I'll ask Jay. Let's put Jay on the spot. You ready? You want to be on the spot, Jay?
I'm on the spot. What's up?
Okay, here's a spot. So what is the biggest hazard when Ronbo says it works? What's the biggest hazard with this connection where they made a connection on the supply side of the overcurrent protected device? What's the hazard here? What's the big hazard?
There's no overcurrent protection device.
Absolutely.
Nothing's gonna make that thing trip. So the
only overcurrent device is that wire.
Burn up.
that wire is basically that wire's a fuse.
It's gonna melt. That's
all it is. It's a fuse. So chances are where it's going to break down first is probably in that wire nut up there, that little blue wire nut or whatever it is up there. That's probably where it's going to break down first, because it's going to melt there first. Okay.
If you guys watch my or follow me on Instagram, you'll see a picture I posted a few days ago, and I showed this to you, Paul, where I went to a water heater, and they had aluminum wire attached to copper wire, and they didn't use a listed wire connector for it, and it burnt and it was melted. So I just see that in this panel right there.
Yeah.
And it wasn't tripping right away. It was still active when you hit the breaker for about a few minutes. So
it's arcing.
It just blows my mind, and it's just crazy. But it was melted. The wire connectors were melted to the water heater inside that little enclosure, that J box. And when I opened it up, I could see it. It was nasty. It smelled like burnt wire nuts, and it was so bad. But yeah, that wire nut, that blue one, it would melt.
So the Robert's right. So obviously this is going in counterclockwise direction on this screw. Like that's the worst of its issue.
Yeah.
But yes, it's definitely going the wrong way.
Good point, Robert.
But there's something else you said about a tap. Here's something that a lot of people don't know is they do make split bolts that will allow you to go from copper to aluminum, right? But I see them installed in split bolts where the copper is right on top of the aluminum. And just because the fitting says that it's designed for copper and aluminum, that's the improper way to use that split bolt. You'll notice that on a split bolt that's designed for both copper and aluminum, it has a little flat piece between it. That goes between the copper and the aluminum. It's the deflector. It's the divider. I don't know how many times I've seen people do those, and they put the two conductors on top of each other and tighten the split bolt down. And that's just as bad. It's two dissimilar metals. Yeah. That's why they have that little flap that goes in between it. You put one on the top, one on the bottom. They don't come in physical contact with each other. It's designed that way. So again, I see that all the time, and I look at it because people are like, "Yeah, put the split bolt in." I'm like, "Yeah, I'm doing copper and aluminum." Yeah, I get it. They go, "Well, it's rated for copper and aluminum." I say, "Yeah, until you installed it. Then when you installed it, you didn't pay attention to the fact that there is a separator there that you put between the copper and aluminum." And they're like, "Well, I didn't know, man." I'm like, "Well, now you do. So you got to fix it.
Now you do. Now you know.
Now you know. So
Go fix it.
Go fix it. All right." Let's do our giveaways for tonight. Jay, did you see who all it was? Now, again, let me give an update for everybody. I have the... Daggone, Jay, it did it again on you. It made you teeny weeny. Dude, I don't know what it's doing to you. I guess it automatically knows that you're kind of small guy. All right, so there we go. Shrunk. So for guys that won last week and everything, we've got your list, everything. I will give you the choice because you did email me. I appreciate it. You can either wait for the bottle opener thing, the new thing to come, because I got to wait for them to be made, printed, and we'll send you your stuff and I'll send it later. Or you could tell me that just to hold it and I'll hold it and we'll send it when they arrive. That's your choice. You know who you are. You sent me an email. Send me another email saying just hold it and send it when everything's available. Or I'll send it. I don't mind sending twice. Shipping don't bother us. Trust me. So we'll send it twice if you want to get your stuff now, and then we'll send you that bottle, the neat little bottle opener later. That's fine. But let us know. Otherwise, I'll send you what I have now.
He says he'll call me on this. I'm thinking he's talking about that last install. If you see that install, buddy, don't call me. Okay,
That's right.
There's nothing I'm gonna do for you. No,
That's right.
Joking. I'm just
all right.
joking. Yeah,
So
I have the names. So first we have Mr. Aaron.
Okay, again. So let me do
with
the spin.
$19.99. So we're gonna give Aaron a nice spin of the wheel.
Stickers. Aaron, you give $19. Do you want stickers? So let's. You probably in the other package you got a bunch of stickers coming. So we're gonna spin again. LED lights. So we'll get you another LED light.
Lights.
Okay. Thank you again for the support for the show. Appreciate you. Who's next?
All right, and then we got Chitty Electric.
Down here in Atlanta. He could come by and by and pick it up. All right. LED light. There you go.
LED light.
Just so you guys know what these are the LED lights. Boop, boop. And they're magnet mount.
Yeah, and if you don't,
boop, boop,
yep,
boop.
they are.
Okay. They don't just
follow him on Instagram. Go follow him. He's on there. Yep, look at that. That's the neuralizer right there.
Yeah, you can do that if you want or whatnot. So anyway, nice to put on the panel. Again, you need to see whatever.
Yeah, they're lightweight too. They don't carry much. Just very lightweight. Boom.
Yep.
Pretty durable too. I dropped one and it didn't. I dropped it at a weight level, but still.
The batteries are replaceable too. So, and you can actually use the little screwdriver to get those little screws out because I did. Okay. Next,
we're going with Mr. Code Strong, Tim Johnson.
All right.
Oh, Timmy boy. Good guy, man. I think he's down there in North Carolina.
That's right. Apex, maybe?
Doing big things
Apex,
down
North
there,
Carolina.
man.
Stickers.
Yep.
Another big batch of stickers. All right.
Now, hold on. Last week he had keychain and sticker. So do you want to set him another stack of stickers or let him spin again?
Let's let him spin again. Unless he has a fondness for the stickers. Oh, I got black. You're a loser. No, we're not going to let that happen. There's no losers.
Oh!
No losers on this one here.
No losers tonight.
An LED light.
LED light. Man, we are on fire. 3 LED lights.
Okay.
Hope you're stocked up on those things. And then we go to Mr.
Still got him.
We're going Demetrio next. Last week he had an LED light, so he needs something different.
All right. Something different. He just got an LED light, so we're going to do it again. And after we get past Thanksgiving, this wheel's going to change with some new items. So, screwdriver.
Screwdriver. There it is.
There you go. So that's this screwdriver. There you go.
Yeah, and I'll send you over a revised list from last week and this week to combine to everybody who's doing it twice. And then we have Mike Schwartz.
Schwartzy.
Good guy, man. Enjoyed having him last night on our exam prep, which we went about, 2.5 hours into Raceway Phil, which was amazing.
Almost 3 hours in Raceway Phil. Again, for those that watched it on the stream, it deletes right away. But for the Fast Tracks guys and the monthly subscribers, you can go watch it again. If you didn't miss it, you can go watch it. It's in there in multiple places on the member area. Under the 2020, it's under the exam prep only. It's under the rebroadcast of Fast Tracks. So it's all the way at the bottom. So I put all the new videos. That doesn't sound intuitive, right? But I put it all the way down at the bottom. Okay. Yep. Forrester, yep. We said that earlier. Yep, I know. They put it the wrong way. But of course, that's the lesser of the evils. It was already so messed up anyway. So,
right.
So, yep, definitely. All right, Schwartzy, we got you. Got the keychain.
What did he get? What did he pull up? He got the keychain.
Yep. What did he get last week?
Let me just see what he got last week. He had LED light and stickers, so now he's got the keychain. So
good. Everybody's getting a little everything. And we'll refresh this up once we get it going.
And let me tell you something, guys. If you want to give a shout out to someone who's not an electrician but donates every week, who's probably funding all the
shipping.
The shipping is Aaron. I tell you what, man, Aaron, and that's my brother, man, here in Colorado. Big supporter for the channel. My buddy Chris Lightsey's on the chat tonight too. He's an iron worker here at the IBEW, I think, through the union. I don't. Is IBE? That's only electrical, right? So he'd be union iron worker. Sorry. So just he's an iron worker through the union. And he's even joining us tonight. So I appreciate you too, man, supporting us. Thank you so much.
Sweet. Who else we got? Is that it?
That's it, brother.
All right, that's it. Let's get back to.
So make sure I will put in.
Oh, it did you again.
The email that they need to send to.
It made you teeny again.
Is it host at electricianlive.com?
Host or hosts? HOST or HOSTS at electricianlive.com. Either way. Oh, wait a minute.
Either one.
Yeah, either one. Hosts. Either one will work. But you
host or host. Did I do it right?
I think so. Electrician
host or host.
Yep. Either one of those.
Electrician Live.
Those. So if we already have your address, you've already sent it to us, and you want to get in this week, don't worry, we've got it already. But if you haven't, or you're new and you did, then So people ask, why do we do the giveaways? Look, people donate. It does help us out. Pays for the shipping and sending things out. It helps the show. You're obviously not obligated to do it. You don't have to do it. Okay. We appreciate it. And all that type of stuff, but it does help us send these things out. Plus it lets us get the new stuff. So that's why we got the new, because we want to recycle in some giveaways. And I want to start giving you things that you can actually use, right? In the field. So let's empty this tip. Let's empty this tip jar live on screen here. Oh, wait a minute. Chris did last minute and donated $5 here. So.
Oh, shoot. Here we go.
Spin it. We got to spin it.
Chris did, huh? Gosh darn it.
Screwdriver
for Chris Lightsey, right?
Yep.
Yeah.
Yep.
Just take a minute. Hey, Chris, does your wife know you're spending that $5, bud? I'm just saying, brother.
Just saying. All right, let's empty this tip jar again. We thank you, everybody. So we're gonna boom. It's gone. So again, we appreciate everything. Hopefully you got something out of tonight's show. We try not to get too cozy on you, but Ronbo's tipped. So he's given a tip. So we're gonna spin for Ronbo.
Oh man, Rombo, right in the last minute. I love it, brother. Keep them coming. Come on.
There we go. Let me give him a spin. Give you a spin, Rombo. We'll get you some goodies. LED light. So again, Rambo, it help you in all that overtime work you're doing at night you can get these bad boys and, shine the light on the work, that type of thing.
Yeah,
did get your text, by the way, Rambo. I did get your text. I've just been so swamped I didn't reply, but I just wanted you to know I did get it and wish you luck with your new partner. What is that saying? First come love, first comes marriage, then comes baby carriage or something. I don't know what it is, but that came to mind when I thought of Rambo and his new partner. All right, so at the anyway, that's all of those things. So let's get back to it and wrap up tonight's show. Hopefully you got something on it. Again, we touched just the surface of equipotential bonding, but you kind of get the gist of it and all the pieces. Tie all the metal parts together, anything within 5 feet, any fixed metal, any metal that is more than 4 inches in any diameter that's associated with the pool. Not going to do the little anchors that go around the perimeter for the covers. If they don't meet the dimensional requirements, then you're not going to bond those. Bond the water. There's many ways to do it. The handrail that's metal might do it if that's got 9 square inches of surface area, which it probably does, unless it's a plastic encapsulated or covered type of rail, then it wouldn't, then you wouldn't have to bond it. So anyway, that's the whole concept, tying everything together so that it'd be no different if I tied Jay and me together with a big 8 gauge all the way to Colorado, we'd be at the same potential. Okay? Same concept. We want everything to be at the same potential around the perimeter of the swimming pool. Okay? 3 feet out. Okay? All the metal tied together. Everything fixed, tied together. Motors, pumps that is associated with the circulating water, all of that. Tie it all together. All right. That's it. That's all we can cover. That's all we can cover on that topic tonight.
Are the donators tonight? Are you throwing in a bottle opener for those guys tonight? For those who don't have one, because some of them already have it.
We can't give those things every week.
All right.
I was feeling joyous last week. I can't do that every week. Come on now. Come on, Jay. Come on now.
No, for those guys that did last week, we will make sure that we get those out to you guys when they come. Like Paul said, we'll probably get these ones out to you first and then follow up with the bottle openers. But we are taking next week off. Yes. Obviously, it's Thanksgiving, so enjoy the time with your family. I got my mom and dad coming down, so we're going to hang out and just
now, if you want
chill and relax.
If you want to see a rebroadcast, then go over to Electrician Live. There'll be one there, so you can watch it there. It won't be on the YouTube channel. It'll be over on Electrician Live, but there will be a rebroadcast of an earlier show that me and Jay did. Okay? Chris, he said, come on now.
Nope.
Okay, because since Jay opened his freaking mouth, everybody that won tonight will get a bottle opener. Again, just write it down, Jay. But stop it, Jay. All right, so anyway. Okay.
I mean, I love giveaways. Hey, did you guys see that box I have? Let me tell you something. I added a few more items to it. Every time I go to a supply house, I'm always asking them, hey, what do you got for me? What giveaways you got for me? I'm your number one customer. They're throwing me hats, little what do they got? Recirculating saws,
reciprocating
all
blades,
kinds of stuff that I have.
Things like that.
Blades and all kinds of stuff. So we're going to be switching it up in a few weeks when I get that over to Paul, and we're gonna switch it up a little bit. But we do appreciate the donations.
We're gonna put some packages together. We'll put some packages together, things like that. Yeah. So cool. Good deal. All right. Well, Michael, good to see you again. And again, all of you next week, for those that listen, next week on Tuesday, we still will be doing our grounding and bonding segment. So you know how to get there. You go to the members area. The link is there. You know how to get there. We will not be having exam prep. That was a great exam prep last night, by the way.
Oh, so awesome.
We will not be having exam prep next week because of the holiday. And we will not be having a live Electrician Live next Thursday, but you can go watch the rebroadcast over on electricianlive.com. So go check it out, and you might enjoy that one. It was a pretty good episode. I'll let you go over and check what that is because it has been updated. So, anywho, till next time, folks, stay safe. God bless, and we do appreciate you as always. Jay, welcome out. Say see you. Later. Later, folks.
Later.
You're listening to Electrician Live with your host, Paul Abernathy and Jay Grunberg.